Hello, I'm Jason Bailey, your host for the online webcast of the Microsoft Research Devices and Networking Summit. I want to welcome you, our viewers from around the world. We're coming to you live from Microsoft Le Campus, Paris, France, where nearly 200 thought leaders from academia and industry have gathered for 2 days of keynotes, tutorials, demos and panel discussions, all centred on research into the ever more connected world. But you don't have to be here to be part of the summit. All you need to do is stay tuned into the webcast. Oh, and be sure to engage with your fellow viewers via Twitter. Just use the hashtag DevNetSummit. Joining me here on the set are two of the summit's events chairs, Steve Hodges and Ant Rowstron, both of Microsoft Research Cambridge. Steve and Ant, I want to thank you for coming on set.
Thank you.
I want to begin by asking in general terms the approach you took in setting up the summit. And I know it's built on devices and networking, and I understand that the important bit is and. So could you just elaborate on that?
Sure. Well, I think it's a really interesting time for computing at the moment. For some time we were very much sort of locked to a desktop paradigm where we were using computers on the desktop, but more and more mobility, using devices on the move in different scenarios is becoming more important. So the devices themselves are changing, and yet at the same time, these devices are nothing if they're not connected, right? They have to be communicating with each other and increasingly communicating with the cloud. So I think the future of computing, that juxtaposition of the devices and the networking component is very important.
Yes, so the two coming together to enable it, yes.
And would it be fair to say that the summit is really exploring the Internet of Things?
Well, I think the Internet of Things is an interesting term because that's a little bit of a buzzword.
Yeah.
And for us, it's perhaps overloaded.
Yeah.
It's hard to know exactly what you mean when you say the Internet of Things. So in some ways, we try and avoid using that term a little bit.
Yes, and so I think this is more general than that. So it's really trying to be very broad, devices in every sense. We've got things like home networking being covered here, and all sorts of topics to do with sort of devices in general and the connectivity of them.
I mean, the next kind of thing I wanted to talk about was the growing world of connections, and I think like a lot of people, I get a little uneasy on security and privacy these days. Are these concerns I should be worried about, or am I overreacting?
So I think these are very valid concerns,
Yeah.
right, to be worried about security and privacy. I think sometimes people worry too much about them, and it's a bit of a sort of, we get a bit obsessed about them. Here we've got several great talks, and in fact online I think you'll be hearing about some work on looking at how information can be extracted from mobile phones and things like this, from memory in the mobile phones, which is very exciting, and ways and techniques of actually ensuring those sort of techniques don't work. You'll also be hearing about some work to do with trying to ensure privacy in photographs. So when people are taking photographs, and we've all got mobile phones these days, we're all taking photographs all the time. People get captured in a photograph even though they're not actually wanting to be in the photograph. They just happen to be in the background. Sometimes this might seem innocuous, but perhaps if it's in a hospital or it's in a gym or it's on the beach, this is more of a concern for the people who are captured, perhaps when they don't want to be. And so we've had a very interesting talk, and I think there'll be on the online version about how we might think about that sort of privacy and how we might build technologies to be able to provide sort of more privacy to those that are captured in the photos.
I think another area people are interested in the world of connections is healthier lifestyles and how they can be improved. We're all aware of the band and similar devices. I'm guessing there's a lot in store with wearable health monitoring. Where do you see this heading?
Yeah, that's a really interesting area as well. So I think we're seeing new sensing technologies becoming available at the right kind of form factors and the right sort of price points that they can be part of a wearable device, like a band, a wrist-worn device, for example. And so one of our research colleagues in Microsoft Research is looking at how we can be smarter about assessing people's health in a continuous fashion. So health is moving away from these instants in time when you go to the GP, for example, for an assessment, and this sort of continuous assessment helps us gather a lot more data about people's health, and then in turn that helps us spot conditions perhaps before they get to the point you would normally have to, where you get admitted to hospital, for example. And so we stand the very real prospect of truly extending lifetime, people's lifetimes by being able to integrate some of these wearable sort of health monitoring technologies.
Another area I guess you're also going to be discussing is education. Students are creating their own prototypes using simple commodity devices and easy to learn programming. Can you elaborate on this?
Yes, so we have another one of the tutorials we had which was around rapid device prototyping. So again, with the proliferation of different types of devices, computer programming, learning about computers and how to program them used to be this quite dry experience where you were in front of a screen and creating this virtual. And more and more, the children of the children who are going through the education system at the moment, there's a danger they become very much consumers of technology. It's very easy for us to be just consumers, and we want them to be producers of technology. And having different ways of engaging them, and so they understand what's important, the important aspects of technology, how to create it for themselves is important. And device prototyping, I think, is a really important element of that. So being able to get your hands onto a physical prototype and manipulate something physical. So it's not about learning computer science and learning the techniques perhaps that you need for programming. It's much more about building a device, and then along the way you get educated.
So moving away from the classroom slightly, I want to ask a few more technical questions on networking and devices. Issues like spectrum availability and domain names.
Oh yes, so let's think about, first of all, about domain names. How do you find things? You've got all these devices out there. At the moment, we have systems which are sort of based on the internet and IP addresses that exist. And one of the important aspects is in the future with all these mobile devices is how do we actually find content? How do we actually ensure that when we've got all these devices, that messages arrive at the correct device at the correct time? And we've had some great talks from Aaron at UMass on techniques that they've been doing to build out new infrastructures to provide more flexible naming schemes to allow you to think about binding, sort of a name to the devices that you're using. The other thing, of course, that's really important is we need access. We need to be able to get devices connected. And one of the things that you need for that is wireless capacity. And wireless capacity is not infinite. It is actually in short supply. And there's a lot of work on white spaces. How do we reuse space which has been allocated for other things, say the TV or things like that, allow it to be reused? And again, this has been an aspect of the sessions here, looking at and thinking about some of these aspects to do with wireless reuse and spectrum reuse.
I noticed that a lot of your interviews, well, a lot of our interviews here, include academic researcher and someone from Microsoft Research. Can you talk about the importance of collaboration within, with the academic world?
Yeah, so I mean, since Microsoft Research was founded, it's been incredibly important to the culture of Microsoft Research and to the company that we have these very tight relationships with academia. So you're absolutely right. Like in each of the sessions, there's as much, if not a bigger contribution from our academic colleagues as there are from MSR people.
Yeah, and I think in the opening keynote by one of our corporate VPs, Peter Lee, he was saying 80% of the papers that we produce have academics and Microsoft researchers on them, which just shows how absolutely important this collaboration is. It's a sort of very symbiotic relationship. There's sort of product groups, there's academic research, and there's research labs in the middle, and they sort of have this relationship where the sort of the interdependence, I think, is really important.
From the get-go, I think one of Microsoft's core missions is to advance the state of the art. Yeah. And so we need to work with the thought leaders around the world who are doing that, right?
Yes.
And do that very collaboratively. But at the same time, there are more pragmatic opportunities sometimes. So sometimes we work with product teams. The Connect was a great example where there's a product that was developed and that created a whole raft of academic research, in different domains, right? Which is taking a technology that we'd made essentially sort of cost effective for a whole load of new application areas that weren't previously. And actually right now there's a collaboration with another product team in Microsoft around the Surface Hub. So this is a new device which is initially been designed for sort of corporate meeting rooms and maybe in education academic scenarios. It's a big display which is highly interactive, so it's multi-touch and it's sort of bristling with sensors and really trying to think about making meetings and making interactions more productive. And I believe there's a request for proposals out at the moment with the academic community, because what we'd love to do is get more academics involved in understanding the Surface Hub technology and how it might apply in other different application domains, for example. So I think we're soliciting proposals from academia. There's a URL, I think it's surfacehubresearch.com, that people can go to get more information about that.
Yeah, there is. And I was just about to say, I'm interested in seeing the potential of Surface Hub, and it just happens that we have a video coming up to show you a little bit more about it.
We want every meeting to be great, where things just click, where ideas flow and work gets done. The problem is, technology hasn't been designed for the way we want to work together until now. With Microsoft Surface Hub, you can unlock the power of the group. You can walk up and share your ideas on a canvas as big as your imagination. You can touch the data you need to make key decisions on the spot. And anyone can pick up a pen to help drive the conversation. It's a platform that brings the tools you rely on to the center of the discussion and lets you interact in new ways. Whenever you need, you can bring the right person into a critical session. Meetings become more engaging and productive, and you can take your ideas with you when you leave the room. So make every meeting great. Introducing Microsoft Surface Hub. Unlock the power of the group.
That was a great video. Now moving on to today's kind of agenda, we've got a number of demos, and I wonder if you can just give us a few teasers of what we might be seeing.
Yeah, so it's interesting. There's quite a variety of demos here. One of the, I guess to start off on the devices end, we have some collaborators at Hassno-Plattner Institute who are exploring rapid prototyping, rapid device prototyping, the physical shape of a device. And 3D printing, of course, is really sort of a very hot topic at the moment. It's a fantastic technology, but one of the limitations of 3D printing is the speed, right? It just takes a while. You can make a custom prototype, but it just takes a while. And so they've been looking at ways of speeding that up, of creating sort of almost like sketches of 3D prototypes. So you can get an idea for a physical shape and the size and the form and the fit, but much more quickly.
Well,
so we've also got someone on printed own writing for doing circuits. Did you want to talk a bit about that?
Yeah, sure. So another technology we're interested in is in the area of device prototyping, but more on the electronics side. So there are a number of technologies coming along, getting cheaper, becoming more available and more sophisticated in the area of printed electronics. And one of the demos we've got here is actually looking at printed conductors in particular. So the fundamental thing you need when you're making electronic device this way is connecting things together, providing the power, providing the communications between the different elements. And so we have a demo where we're actually using a special type of silver ink. There's this relatively recently developed silver nanoparticle ink, and in particular, so it's got these tiny, tiny particles of silver. And in particular, some of the latest inks, they have to, in order to turn conductive, it's not initially conductive. In order to turn conductive, it has to go through a process called sintering. And you used to have to do that by baking. But now you can get low temperature sintering. So almost you can put the ink comes out of a pen, and at room temperature in front of your very eyes, this black non-conductive ink turns into pure silver. So it's it looks like alchemy. The silver's there all the while, so it's not. But the advantage of this technology, you can put it in a regular inkjet printer, as it turns out. And so your ink, $100 on Amazon, you buy the standard inkjet printer, and you can turn it into something that is actually printing a conductive circuit. So it makes it very much quicker and easier to fabricate electronic devices.
And you actually stick the components on, don't
Yes.
you? So you print it, and then you get your components like a battery and an LED, and you can put them on and put a switch on, and it really is
a working
circuit. I mean, it's absolutely sort of
amazing.
amazing.
looking forward to that demo. Well, we certainly have a day packed with information, and I want to thank you both, Ant and Steve, for stopping by and setting the stage for the Networking and Devices Summit. It promised to be thought-provoking and an educational experience. So speaking of education, stay tuned for a live interview on how students are using simple devices and easy-to-use programming languages to quickly create their own prototypes. But first, let's take a look at one of those wearable health monitors that Ant and Steve have talked about as we learn how Microsoft Research is working to expand the functionality of the band.